For this problem, what we want to find is the volume of the solid obtained by rotating the region bounded by all of those curves. So first step first, let's try to draw the curve. So y is equal to x squared. That's just a parabola. Now, x is equal to y squared. What that means is that you are actually choosing y and you are getting out x. So if you put in 1 for y, x is 1 squared, which is still right there. If you put in 2 for y, x is actually 4. X is y squared, so add 2, x is 4, so x is way over here. And if you put in 0 for x, 0 for y, you get 0 for x. So x is equal to y squared is that. They want us to rotate this around y is equal to 1. So what's y equal to 1 right there? So they want us to rotate this region about that line. Before, we talked about, well, the disk method. The disk method only have one equation and is rotated about an axis. But here you have two equations and it's not rotated about the axis. It's rotated about some other line, meaning the region itself is not bounded by the axis. Then what can you do? Well, we do the exact same thing we did before. We try to draw our disk. Except our disk is now this little space in there. That's our disk. What is the area of this disk? If you take a look at this, if you can imagine, if we take that disk and we rotate it about that line, we are not actually getting a disk. We are actually getting some kind of a washer or a donut. And this is why this is called a washer method. If you actually rotate this thing, that little black box is going to look something like this. If you look at it straight across. Well, then what is the area of this washer? The area of this washer is going to be exactly the same as we did back in finding area between two curves. It's going to be the area of the big circle minus the area of the little circle. What all of this mean is that one, if we want to find this area of this washer, just like before we rotate about an x-axis, we take integration with respect to x. Here we are still rotating about some horizontal line, so we still take integration with respect to x. And the area is going to be given by the area of the outer curve. So pi r squared of the outer curve, the curve furthest away from the axis of rotation. Instead of saying top and bottom, I say outer and inner. Minus the area given by the inner curve, the curve closest to the axis of rotation. In this case, it's pi. The area of the outer curve is going to be given by, and the area of the inner curve is going to be given by pi 1 minus, well, due to the fact that this is x with respect to y, we have to solve for y with respect to x. And again, we are taking the positive y because we're in the first quadrant. So 1 minus the square root of x squared. Note that we have to do this 1 minus right here. It's because we are rotating with respect to the line, well, y is equal to 1. Meaning we are accounting for this portion right here. If we just put in x squared, we are actually counting that portion on the outside. We're actually rotating about that portion. So if we want to find the radius, it's going to be 1 minus the outer curve. And then from here, it's all the same. Just take the integral, just set up the integral. The integral is now going to be from 0 to 1. We are running around the x-axis, so around about a horizontal axis. And then ax is going to be pi of 1 minus x squared minus pi 1 minus the square root of x squared dx, which is going to be equal to the integral. Well, we can just pull off the pi to the outside. Multiply off that out. 1 minus 2ab, so 2x squared minus plus x to the 4th. That's a minus, so on the inside it's going to be 1 minus 2x square root of x plus x dx. Pi integral from 0 to 1. 1 minus 1, that's going to be 0, so minus 2x squared plus x to the 4th minus x minus 2 square root of x. Integrate. Minus 2 over 3x cubed plus 1 over 5x to the 5th minus 1 over 2x squared minus the integral of that is going to be plus 1 to the x to the 1/2, and then bring that down, meaning divide by the new exponent, so it's going to be 4 over 3. Evaluated from 0 to 1. Again, at 0, everything is just going to be 0 anyway, so we just care what happened at 1. Plus 1/5. Sorry, that should have been a plus right there. So that means that should have been a plus, and that means that should have been a plus, which is equal to pi 2/3 plus 1/5 minus 1/2. A fifth minus a half, that's going to be multiplied by 2, multiplied by 5, so minus 2, 3 over 10. And then all in all, that's going to be pi multiplied by 10, multiplied by 3, so 20 minus 9 is going to be 11 over 30. So for this problem, I just want you to note that whenever you have two functions, just exactly the same as before in 6.1, to find the area of the washer, we take the area of the outer function minus the area of the inner function. Of course, the drawing is going to help you greatly in these kind of problems. It lets you see, okay, how do I find the area of this disk?